Rate of change is a really important idea basically in our day-to-day lives, in everything that we look at. Although we may not call it rate of change, we deal with it all the time. So one of the most frequent ones that we run into is constant. So you go to the gas pump, and if you look at recent gas prices, you might find that you probably pay around, you look at the pump, and for unleaded, I don't know, any particular pump that I've seen recently has been about $3.03 per gallon. And just to make this even easier, I'm just going to go with 3 to have a nice even dollar amount. Okay, so unleaded is $3 per gallon. Now we see this in a lot of different ways. We see it written out in words. We might just look at the gas pump and we might know exactly what they're talking about already. But what is it that we really know? What does it mean to say $3 per gallon? Well, the 3, of course, has the units of dollars. And the $3 applies per, well, how many gallons is this? Well, it's really only 1 gallon that you're getting, right? You're not getting 2 gallons or 10 gallons or 15 gallons. You're paying $3 for every 1 gallon. Although we usually just say things like $3 per gallon, $1.99 per pound, 9 cents per kilowatt hour, if you're familiar with paying an electric bill, 40 cents per minute of overage charges. We have so many things that we deal with, especially in money on a day-to-day basis. But what's another way we could write this? Well, in math or in sciences, usually we write units off to the side. That doesn't mean you have to, but this is just another way to write it. And by the way, the abbreviation for gallons is GAL. You don't want to use G because G typically stands for grams. So $3 per, remember this guy is the fraction bar, we sometimes just use the word per to represent it. 1 gallon. So the units, really this idea of units and dollars per gallon comes about from the idea of division. It's $3. It's a ratio of $3 for every 1 gallon. So what can we do with this thing? Well, this is, number one, a constant rate of change, because it doesn't matter how many gallons you purchase, it's always going to be $3 for each additional amount. And I'll just casually refer to this as the CRoC. So we are dealing with a big CRoC, constant rate of change. So $3 for 1 gallon, and I'm just going to be consistent all the time and always place my units off to the right, is the same thing as, if you, hopefully you agree with me, if I purchase 2 gallons, then that's going to cost me $6. That's the same idea as if I purchase, if I spend $100, I won't say $100, I'll just stick with changing the gallon. So if I purchase 100 gallons, well, that's going to cost me 100 times the dollar amount, right? Because 1 gallon cost me $3, 100 gallons will cost me $300. Okay, but look at all these ratios. 3 to 1 is the same thing as 6 divided by 2. This comes out to 3. This comes out to 3, 6 divided by 2. And this comes out to 3, 300 divided by 100. So it's a constant rate of change. It's regardless of how many units of output for the respective units of input, it's always the constant ratio in terms of the rate of change. So how do we get that? Well, whatever I want to do to the base ratio, which again we typically see $3 for 1 gallon, is if I want to adjust the number of gallons. Let's say I want to go with 50 gallons on a big truck. Well, that's really just 50 times 1. So if I multiply the gallons by 50, I also have to multiply my price by 50. And a lot of people probably do this in their head and say, well, that's $150 per 50 gallons, which again you'll notice is still 3 to 1, still a 3 to 1 ratio. The cool thing about thinking like this is if I perhaps say 1.23 gallons, well, I can just take my price and multiply it by 1.23 because it's a constant ratio. And just to show how this works out, I'm going to pull up my calculator. 1.23 times 3 will give me $3.69. So $3.69 per 1.23 gallons. And I can say that for every 1.23 gallons I buy, I'm going to pay $3.69.